Hello and welcome to Identity Office Hours. I'm your host, Mike Schwartz, founder of Glue. Today is episode 153. Please follow the live stream. Quick reminder. Our guest today is Nicola Gallo, CTO of Nitro Agility and co-chair of the Trusted AI Agents Working Group at DIF. Welcome, Nicola.
Hi everyone, nice to be here. For sure, it's gonna be an interesting chat with Mike.
And we're going to skip the normal background because Nicola was a guest on episode 88. And so you can check back to that episode if you want to hear his background. We're just going to dive right into the content today. The topic is another episode on AI identity or AI agentic identity. How surprising. The title is AI agents and the layers of trust from confusion to decentralized machine identity. So cool. Let me dive right into it and ask you this first kind of existential question, Nicola. Why do agents need identity, especially if they're ephemeral? And do they just need a unique identifier, for the audit logs, or if agents need identity, what are the claims that we really need in order to do authorization? So sort of an existential question to start with. Why do agents need identity, period?
Yeah, for sure. So first of all, the identity, why is required? As soon as we want to delegate an agent, because what's the change of the paradigm that we've got here? We want to delegate an AI agent to do something on my behalf. So the first point is, if I want to delegate, I need to delegate someone. So if I don't have an identity from the other side, there is no delegation. Okay. Then, in terms of identity, for sure, the workload they have to be ephemeral, because in terms of auditing, you want to know exactly which instance did something, which instance got some problems. Okay, but this doesn't mean that the authorization layer is going to be tied to the ephemeral ID. In my opinion, where the industry at some point will move is to idea to have a verified credential, okay, for the machine. You're going to have ephemeral identity, workload identity for each instance, for each workload, and this workload is gonna get all the metadata from the verified credential, and you're going to build the authorization on the metadata of the verified credential. So let's suppose I've got some authorization and I say, look, I want to make sure that the only workload which is able to execute this action is a workload which is part of the HR department. So you're going to have some verified credential. They're going to be attached to the hardware. For sure, the workload ID is going to be ephemeral, but you should be able to see that actually that workload belongs to the HR department. I don't know if that answered your question.
Let's unpack that a little bit. So it sounds like you're on board with creating a agent identity based on attestations, and those attestations could be from the hardware, or from the operating system, or even from the application. For example, if I install a mobile app on my phone, I can get an attestation from Google about the checksum of that software to make sure it hasn't been, changed. So the idea that trust is sort of built up from bare metal to operating system to application through attestations. Um, how do we go the next level? But all of those attestations don't get you to an identifier per se. So, what is the right identifier?
So in my
Given these
opinion,
attestations?
the right identifier in this context are the date. the decentralized identity identifier. So what is the point? When I've got an identity, it has to be somehow unique. So I have to be able to embed it, for instance, in a verified credential. So that's the one that I think is going to be used. Then, of course, you've got other type of identity like SPIFFy ID, which are great. But at some point, we will need to bridge the two type of identity. So we're going to have identity like the DID for the public internet to build trust across different area. Then within the private boundary, we might have SPIFFy ID. But in my opinion, if the SPIFFy ID were already using a DID format, would have been much better.
Okay, so let's unpack Spiffy a little bit. So Spiffy provides a registration flow that allows you to obtain a unique URI, and then that can be provided through a certificate, X509 certificate, or some type of JWT, right?
Yeah.
And the identifier normally is a URI, and so that process works. But what are the problems? What are the challenges or the limitations of that? Why do I need a DID if the URI is a globally unique identifier? Why do I need a DID?
Yeah, but is it unique in that space? I mean, when you got the DID can be cross identity. So I'm gonna have two different type of identity: human and non-human identity. In a verified credential, I might have a DID. I'm not gonna have a SPIFFy ID in a verified credential. So what's the point to have two different type of?
Why not? Why not?
I mean, you can have, but there is no point to have different format. I mean, if you want to be to build a unique security, because what is the problem? The main problem where we are today is to have two different type of security: one for the public internet and one for the private internet, for the enterprise. I mean, all the challenges that we've got today with the AI agents is because of this. So we were building two different security model. As soon as the AI agent they start to communicate with the internal part of the company, the problem starting to be evident. So I think if we are going to build something new, at least we don't make the same mistake.
How exactly does a VC differ from an OAuth token?
I mean, the main point is that is decentralized. So you can have both of them, but what is the main point?
Can we start with the basics? These are both JWTs, right?
Yeah. But
Okay.
you've got, I mean, you don't need to connect to the identity provider. I mean, you got the verification, you got the holder. You can present, you can, with your verified presentation, you can just present what are the data that you want to present, and that's it. So the main problem comes from the model. So we have identity provider that are centralized. How everything started. Before the company started with the username and password, then they started having this account. Those accounts are managed by the identity provider, but essentially I'm not the owner of my
I
account.
understand that you want to make a presentation from the wallet. So is that what you're saying? Is that you want to present this thing from the wallet, but we're still talking about a JWT, right?
I mean, but the problem is not the JWT. I mean, the format is not the problem.
What is it then?
You can use a JWT. The problem is not the JWT. Also, the SPIFFy can be a JWT. I mean, everything can be a JWT.
Because in OpenID for verifiable credentials, it is a JWT. So what type of artifact are you presenting that shows this workload identity or this agent identity?
No, wait. So there are two different problems. So In my opinion, the problem start. The main problem is based on the fact that this is a multidimensional problem. So all people have been looking at the problem from the same perspective. So I get your point. You keep looking from the off perspective and you say, look, yes, this approach has been working so far. Why we need to change it? I mean, I can have off, I can have off, integrate verified credential, whatever. Okay.
I mean, I think I'm all for changing it. People frequently say that I'm too optimistic about my desire to change. So I'm not against changing it, but I just don't even understand what you're proposing, to be honest.
Wait.
Uh,
So, but what is the point? Let's suppose why the industry got this problem. So the AI agent, they are not a new problem. They are an existing problem. I mean, it's a few years that I'm saying this, before the AI agent were coming. So let's suppose I've got two workloads, okay? Those two workloads, they need to communicate with an asynchronous channel, an Apache Kafka. What is the point to have off? Where are you going to send your JWT token? I mean, if you read the WIMC specification, what they say is that you don't have to pass a valid JWT token in an Apache Kafka. Okay, so as soon as you start building distributed system, and in distributed system, asynchronous operation are the norm, things breaks. This is the reason why company, they had the perimeter, they had the API. Fine, as soon as you start receiving requests via API, HTTP, everything works. Then once you receive the request, at that point you need to start working on system integration, and the system integration is asynchronous. You've got a bus, a broker, and so on. You cannot use that. That's why company inside, they have a different way to handle the process, and not always are the best. So what is the problem with AI agents? AI agents, they are just exposing this, because an AI agent, what wants to do? Wants to orchestrate a process. So when you orchestrate process, you have two ways to orchestrate. Or you orchestrate normally, or you have choreography. So orchestration, there is one problem. When you orchestrate, you need to persist the state of the workflow. You need to persist the token. Okay. So if we keep persisting state and token, we are going to share our token everywhere. So that's one way. But there is one point. When building orchestration doesn't scale. Then if you want instead to start scaling, you need to use choreography. Choreography is based on async messaging. Okay? So if you want to build an async messaging flow, you need to have a bus. In that bus, your JWT cannot go. So this is the main point. So MCP, why is struggling in the enterprise? Exactly for this, because they want to orchestrate something that is not synchronous. And of course, off is showing its limit, and this is not something new. Corporate, they were not using it already in that type of architecture. I don't know if it makes sense. So if we want to build something new, we don't have to keep looking at the problem from the same perspective. We need to change and say, okay, let's suppose my use case today is to have two workloads. They've got two identity. They are communicating via async messaging. Now, give me a reason why I should use off.
when if you want to take a step back on agents, I
Yeah.
saw a study recently where they said, 45% of agents were using just API keys, like no, not even like a secret, just like a bearer, like a string, a long password. 8% of them were using OAuth.
Mhm.
And I'm not sure what the rest were doing, something in between. Um, and so, to me, it seems like agent identity is not really a problem per se, but just like they're so excited about connecting to each other that they haven't really gotten to the point where they say, okay, what should I connect? and how should I, how should I properly authorize it? But let's actually start there. And the other thing I would challenge you on is there are bad ways to use OAuth. If you obtain a token and you keep replaying that token and you rotate that token, and you don't, and the receiving party doesn't have any cryptographic way to verify that you're actually the possessor through proof of possession on the token. Yeah, there are lots of ways to do OAuth badly. You could not check for revocation of the token. You could maybe not even check the expiration or NVF. So is what you're saying, does it amount to don't use OAuth wrong?
I mean, there are two things. I mean, for sure, protocols have to be used in the right way. I mean, if they've been designed for a certain purpose, you need to use in the right way. But also, if we look at Spiffy, why we've got today Spiffy? Because someone start looking at the same problem on a different perspective. Otherwise, they will be using OAuth. And that's something that let people understand that, okay, there is something different. And once again, when you go in front of an enterprise company, you cannot.
Let me just pause there because I think it's an interesting point that you make about why didn't OAuth solve Spiffy, what Spiffy solves? And the answer is that OAuth allows for dynamic client registration, which is creating a workload identity. But nowhere in OAuth in the past have they allowed you to assert your identifier. The identifier was always issued in the sort of namespace of the issuer. And Spiffy said, okay, well, we want to create these attestations, and the workload has its own. We want the workload to start with an identity before it hits various OAuth servers, so we can correlate this workload across OAuth servers, for example. So I would say OAuth never said that they were issuing you a globally unique identifier. There's no API in OAuth that ever said that that was the point or that they were going to do that. So I think Spiffy was an initial solution of that. I think, ultimately the next generation of this, I think, is going to add better authentication capabilities like in Whimsy. But I think I just want to push back a little bit that Spiffy does something that OAuth never tried to do.
Yeah, but the point is, as soon as Spiffy does something that OAuth never tried to do, which means OAuth didn't and doesn't, and I've got two workloads, and I've got my identity because Spiffy fixed my problem, okay, and I've got this bus. Still, I cannot see any reason to use OAuth. That's the main problem.
Spiffy fixed your identifier problem.
Yeah, but you have to take this use case. You cannot go in an enterprise.
It didn't tell you the of the workload. And ultimately, the identifier of the workload is useful for audit logs, but it's the claims of the workload that really are useful for authorization. So I'm wondering, when you say Spiffy fixed my problem, I'm wondering what problem
Spiffy is not for everything, okay? So another thing that has been happening in the industry, which is quite interesting, is the service mesh part. So there is ambient mesh. I don't know if you had a look to it. So with ambient mesh, now what you've got is that you have zero trust Z tunnels. As soon as the traffic is moving, okay, the pods, they are going to receive the identities. So you've got your identity that can be Spiffy ID identity, okay. Your receiving pod is going to receive the peer identity, maybe soon the self identity, okay. But before to arrive to that pod, you can also intercept this request with a waypoint and evaluate if you are entitled to execute this action. This is done both with the GWT token or whatever you want to send as an attestation. And then you've got the identities. Okay, so this is something interesting. Why? Because as soon as the service mesh is building this layer, essentially you are building what I named to be a trust plane. Okay, at that point you start fixing many of the problems that OAuth didn't try to fix yet. So you've got the trust plane that is going to receive the identity. The trust plane is going to certify that identity. You are going to build an authorization model on it. Then you say, okay, but that's an ephemeral ID. Yes, but there is another important point. At that level, you can start bridging SPIFFE ID with did. You can start enriching also the context with decentralized information. You can start building decentralization also in the enterprise. I mean, this is something that slowly is happening and is building a model. So I think the conversation is not to see why OAuth didn't. I mean, it didn't, and that's it. But there are emerging models that actually are working and they are fixing all this problem. Another use case. Let's suppose I've got...
Pause you there for 1 second. So would, if SPIFFE returned a did, would you like it more?
No, but I'm a big fan of SPIFFE. Yeah? I'm not against
I'm
SPIFFE.
just wondering, so the advantage of a did is that
It's just for convention. I mean, if you want, it's not a big problem. That is not a did. If you can still bridge the ID, it's not a problem. Okay, you can translate. But the problem, what I'm pointing out, is that as something already existed, I mean, can be good to match both of them. But if SPIFFE ID stays as it is, it's not a problem. You're just going to map it. You're going to bridge it. I mean, I don't see a big problem. The interesting part is that SPIFFE is enabling a new model. I can see Service Mesh is already start using this model. I can see already enterprise looking into this and say, okay, if I've got machine, I can start building proper distributed transaction. And another point to add, as soon as I've got distributed transaction that go through a service mesh, okay, if I've got a valid trust plane, what I can do, I can start also going through the messaging, because if I've got a trust plane that is supporting me also to sealing and unsealing the messages, I can keep continuing the trust flow. So the big part that is happening is this, that we are starting to build this new security model, which works also on a single flow. And my question is, okay, once I've got it, what's the reason to use OAuth at that point? There is no point to use OAuth at that layer. I mean, I'm going to use OAuth to log into my browser. It's fine. But there is no point. If I've got two workers that are autonomous, if I've got two AI agents that they start doing something because of an event, I don't need to involve OAuth. That's the main point. I don't know if it does make sense.
So I'm wondering, where are these AI agents running? Are these AI agents running in the cloud, or are these AI agents running on a device that maybe gets disconnected?
Yeah, that's another point, because the point is that you can be disconnected, because all the distributed system, they work based on the CAP theorem. So you can be consistent and partition it, or available and partition it. Okay, so the only way to support the scale is to deal with the availability and partitioning. So it means you are not going to be consistent. So all the NoSQL, they are available and partitioned. So what is the point? The JWT token is just a way to fix the latency problem, because I don't need to go every time to the central server. I got a static snapshot of my claim, of my decision, and I'm going to propagate it. Okay, but that's static. What is the problem? AI agents, they are not static, they are dynamic. So how can you get a static token play with a dynamic model? And
Right.
in the meantime, if
Are you
there is
thinking it's static because you don't think we should check for revocation, or revocation status checking is not, that's not commonly done today? But if revocation status checking were done, if no policy could pass, if the token had been expired centrally, would that satisfy your concern that
So I'm
this?
going to give you an example just to understand better the use case. So let's suppose I've got two network segments, segment A and segment B.
Yeah, and before we go there, I also want to say we're normally talking about like a minute here. So the token is asserting this truth. Hopefully, this truth is good for a minute, but in some cases that's not sufficient, and we might need a refresh of that. Um, so, but I want to say we're normally talking about short time frames here anyway. But you're saying that's static because that minute is too long and things could change in that minute, right?
Wait, what's the point to use a token? I might go back to the server for any check. But if I go back to the server to any check, it means I need to be always connected, and I'm gonna take the latency. So it's not gonna work on internet. So I'm
So
gonna
the way
take a
token status checking works is that there's a token statusless endpoint at the issuer, and you're right. With the if you want to do a real-time check, you'll need to get the latest token status list.
yeah, but here the use case.
Systems don't scale. So
Yeah,
the
but
polling
here the
system.
use case I was giving to you. So first of all, a status list makes sense if you want to check if a valid token is still valid. If it's already expired, I need to refresh. I don't need a status list. Is that correct? Yeah. So when I've got, let's suppose that I am within the time frame of the token. I've got a status list, and you say, look, I'm fine because if the token is revoked, I'm going to use the status list. I've got two segments, segment A and segment B. So segment A request to the network, to application in the network of the segment B to do something. Okay. Segment A, the identity provider, they get disconnected from the network. You cannot communicate anymore with the status list. What do you do? So that's an illusion. So the status list is just an attempt to see if I can get an expired token, but you suffer the same problem. That's another problem of
It's a
connectivity.
more efficient way to distribute the status.
Yeah, but
And
if you get disconnected, you don't distribute. So what are you gonna?
that's always true with everything. If you get disconnected, you always only have the last copy of the information, and
Yeah,
so
but this means
but security is not about perfection, right? Security is about cost, and they say don't let a perfect plan get in the way of a good plan.
yeah,
If we can sufficiently mitigate risk, the token lifetime is short, and maybe it's not short enough. So for certain transactions, we maybe will take the expense of a round trip. So when you're doing a wire transfer, we're going to let you present the token when you're, let's say, viewing your statement. But when you go to do a wire transfer, we need more freshness. So we're actually going to check to make sure that token that you're using hasn't been revoked.
yeah.
So and then in any case, maybe we grab a new token status list every 30 seconds because we don't think that a minute is too long.
If
So
there is connectivity, but here we are once again to the same point. So the model is still the same because you are looking at the token. But if you start looking in a different point of view, maybe you can start thinking also a different type of trust, where one part of the trust is the token, one part it's on the policies. You can synchronize them. You can synchronize policies. You can synchronize token. You have two way of communicating. It's not going to be just the
but only if you're connected, right?
exact, but the value of the token is almost the same of synchronized the policy. So it's not guaranteed to be the best one because when you've got the policies, you've got a valid policy that you synchronize and you can use also during the disconnection as long as there is someone asking for some a request and has the way to certify, maybe with a verified credential, that is the owner of that resource. But instead you are centralized, this use case cannot be managed. So they are both, none of the solution fix all the problem. But what I'm trying to say is, look, when things become distributed, the idea of just relying on a token is a problem, and the status list might be an illusion to fix the problem, because you've got the same problem. If you get disconnected, there is no update.
Let's talk a little bit about crossing trust boundaries, because that's one of the challenges here. The agent is doing stuff on your behalf. It might be invoking MCP servers. It might be calling APIs. Who knows what the agent is doing? And it might be doing this over different across domains. So updating your Google Calendar and maybe updating Slack at the same time. So different, maybe updating something in your corporate database, right? So potentially we're talking about multiple domains, and so traditionally we establish trust either by trusting some root CA, or by coming of some type of federated model, where each domain maybe has their own root key and is trusted through a federation publication. How is the trust model that you're suggesting for how we cross domain boundaries different from either the PKI model or, let's say, the SAML federation model?
I mean, in this use case, this is something that I'm lately thinking about. Let's suppose I've got a request. So I've got auth token, SAML, whatever. Okay, that is gonna be my initiator. Okay, as soon as I got this request, I think that if we want to create real distributed trust, the only way is to create a trust chain. So each element is going to anchor to the previous attestation and see, okay, can I prove I was valid? I could execute this action, yes, because maybe I had a JWT token. So I've got a valid attestation that I was in charge. So let's suppose I've got an AI agent with its own identity and say, Bob, ask the agent, can you do this for me? So the AI agent, what it's going to do is going to take the attestation, it's going to call the trust plane, it's going to say, can you produce for me a trust plane attestation that I received this authorization? If so, you're going to build a chain of requests. This chain of requests can go both via HTTP, gRPC, messaging. When you need to change the security boundary, you need to trust the different trust planes. So you may have different trust plane, okay, that they are distributed authority, and those distributed authority, they can be the mean in the to federate these different security boundaries. And it's decentralized, it's not centralized.
It sounds like a very challenging thing to implement.
No, I mean, if you look at, once again, if you look at ambient mesh,
the counterpoint to how I see this actually resolved today in the world, what I see is that creating a trust chain, it becomes very difficult for developers to validate trust chains. Our developer at Google, who was working on OpenID Federation, told me that the trust chain validation part was the worst, most difficult validation he's ever seen problem.
yeah.
And so what we actually see in the real world is that at every domain boundary, you do a token exchange. So,
But the point
the
that
access token that I was issued can't be presented at any downstream APIs. That every time you cross a trust boundary, you're actually required to do a token exchange and get a token in the domain that you're actually calling.
I would implement is this. I've got a valid request, then I create an envelope a trust envelope. I wrap the access token. The trust envelope is going to be used just at infrastructure level. When you go back to the app, the infrastructure is going to unwrap and send back to the developer, the JWT. The developer is not going to be involved in the trust plane. It's the infrastructure with zero trust that is going to become trustful. That's the main point, the difference. So the point is to push everything on the network. That's why the work they are doing on service mesh is important, because it's going to push the focus at that level. Then you're going to have SPIFFy-ID. If they become decentralized did as well, you are going to be able also to start testing decentralized models. That's what I think.
And so in this agentic model, where we established that the agent could be running on the phone or the device or on the laptop, right? So could you actually describe to me what's your ideal state for how you would build up the attestations, and which workload identities would you actually create? Like, what's your ideal state look like?
Okay, so when I've got, let's suppose I've got a watch. That's the point. I need a verified credential. I need hardware attestation. I'm going to build my initial attestation. As soon as I have my attestation, so from my verified credential, I build a request. This request is going to request something to the AI agent, okay? So I have a verified credential, I have the AI agent, I'm gonna have an identity, and from that point, I'm going to start the trust chain I was speaking about before.
So your watch created an attestation?
An hardware proof.
Hardware. So your watch creates an attestation, and then the AI agent takes that attestation from your watch, and then it somehow obtains an agent identity. How?
No, the identity, the AI agent identity is going to be on the hardware. There are two different things. There is the owner of the watch who can provide its identity with a verified credential, whatever, with its own wallet. Okay. Then each AI agent is going to get attestation that somehow are embedded in the hardware. So you are going to have an hardware that is going to have your certificate. From that certificate, you're going to get the identity of the AI agents. But there are two different points. That's the authentication of the AI agent. The things that I'm working on.
If you say certificate, you mean an X509 certificate? The AI agent is going to obtain an X509 certificate from somewhere?
Yeah, that's, depend. The point is that the SPIFFy is good. For sure, if you're in a watch, you cannot use a SPIFFy. It's clear, it's too complex. They are going to be, in my opinion, the way I see is
SPIFFy is for infrastructure. If you have a server or something, that gets a SPIFFy ID. But yeah, generally, if stuff running on the device doesn't use SPIFFy, right?
But that's the point. In fact, I'm not saying that the company should stop using auth. I never say that. You're going to have multiple ways to authenticate. It's fine. It's going to be auth, it's going to be SPIFFy-ID, it's going to be wallet, whatever. But all of them, they are going to collapse to a single security model for authorization. That's the change, in my opinion. And if I am in the use case where I have two identified hardware workload with SPIFFy, I need to use this authorization model, but I don't need in that case auth because I'm already authenticated.
Okay, so starting back from my watch.
To be more specific, what I'm saying is that auth might become less central in the industry respect to today. That's what I'm saying. I'm not saying it's not good, it's not great. It's a great protocol, but it's time also to look at things in a different perspective.
Yeah, I'm trying to understand what that different perspective is, actually. So I start from my watch, which interestingly neither one of us wear one, because we
Yeah, but
always have
again,
the computer and staring at LinkedIn. Um, and then the watch creates an attestation, um, and that attestation allows me to instantiate an agent that obtains its own agent identity and starts interacting with the internet, you calling FTP servers, calling APIs, and what type of identity, I guess, in your ideal state. Um, and we've ruled out Spiffy because Spiffy is for infrastructure and not for stuff running on my phone or on my watch.
that,
So, what does that agent identity look like? What's the identifier it uses? How does it
once
obtain that
again,
identifier?
as
And
we
what
are
are
going
the artifacts
as
that
this
it
is
presents?
an example to show that we are going to have multiple ways to authenticate because PIF is not great for a phone. No? That's why we should have a universal way to identify identity like a DIT. That's probably the reason. Because if you're going to have one ID for Spiffy, one for a new technology for the watch, one for off, I mean, what's the point to have all this way to identify the same thing? So if you use a specification like did, can be universal. Then, of course, you're going to have different means to authenticate on each device. On the browser, I might be fine with off. On the watch, no. On a workload on the cloud, I may be fine with Spiffy. That's my point.
From my perspective, when I look at DID, what I see is a more formalized way to get back discovery about that identifier. So because if it's a DID, I assume it has a DID method, and I can use that DID method to get back a document of some type or a response of some type, which is an improvement over, it's like a built-in DNS, let's say, for
Yeah.
discovery. Other than that, DID doesn't mean anything. In terms of it being a unique string, it's just as a unique string as a URI is. So from an identifier perspective as a primary key for a search filter, it's not any better or worse than a URI. And so I'm just trying to understand what is the use case for DID documents that's so compelling that means that we should that URIs are failing. What could we do with DID documents that we can't do with URIs, which have no standard way to resolve their capabilities?
Yeah, but my point of view is not that much. I mean, you've got the identifier. I mean, what I'm trying to build is something that is different. So I've got the identifier. I don't care if this is an identifier that comes from off, SAML, verified credential, whatever. I'm pushing the focus on a different thing. Say, okay, when I receive a request, okay, and I need to validate, the first thing is that I need to understand which one is my identity. So if I am a workload, my workload identity, who is calling me, who is my peer identity, who is the initiator, the attestation that show why this distributed transaction started. At that point, okay, the policy decision point, what is going to start to do? Is going to start working with the trust elevation, meaning uh, instead of to get the application code that is going to check, can Bob execute this action? The first question has to be, can this workload elevate its authorization context to the to my workload ID. So I'm going to have the peer identity can elevate to the self identity. Can the self identity elevate to the Bob identity? In that way, you start building also governance because let's suppose you have. I'm going to give you another example of segmentation where many people they start looking into it, asking questions because they are saying that actually there are no solution. So let's suppose I've got two network segments, okay? And I have the same policy. So you have your CEDAR policy that are embedded in the code, which are static, okay? I have two segments. One of the segment is under attack. The security team realized that certain type of operation should be not done on that segment. Okay, how can you can actually make sure that only that segment cannot operate on something very specific, even though they have a valid token. So if you do impersonation with the auth token, you cannot fix this problem. If you start building in terms of elevation, you can. I don't know if
Yeah.
if
Attenuated delegation was one of my questions, but I think that we're going to have to save that one for the next episode. Nicola, any last thoughts before we break?
So it was good to chat with you, Mike. Hopefully this was helpful for many of you. I mean, I'm keep working on PermGuard, which is an Apache 2.0 project on GitHub. If you are interested into it, you can have a look. That's
Awesome.
it.
Cool. So the next episode, we have the founder of Stitch, or one of the co-founders of Stitch, coming on. So I'm really excited to talk with Reed about acquisition by Twilio and what's on their roadmap. So with that, I'll say thank you very much, Nicola. Great conversation. We went pretty deep, and thank you, audience, and we'll see you next time.
Thank you.